Good morning. Chapter 8, Lesson 3 is on page 371. Today we're going to learn a new method. First we've got the graphing method on 8.1. We had the substitution method in Chapter 8, Lesson 2. And finally in Lesson 3 we're going to learn the third method, which is either adding or subtracting for two linear equations. Number 13 says solve. Minus x minus y is equal to 8 and 2x minus y is equal to negative 1. Let's look at these two equations for just a bit, and we're going to see if we can either add or subtract something and see if we can make it work out. What I'm going to do is I'm going to just put some parentheses around this to help clarify it for just a little bit. And what I'm going to do is I'm going to say maybe we can subtract the second equation from the first equation. So I put these parentheses around here so they can kind of keep us organized as we start. So let's see if we can do that. Minus x minus 2x. Minus x minus 2x is going to give us minus 3x. Minus y minus a minus y. Remember, we got bling bling here, so these are going to cancel out. So we have minus y plus y is a 0. And it's equal to 8 take away a negative 1. 8 take away negative 1 turns out to be a positive 9. Bling bling again. So this looks like minus 3x is equal to 9. Or x is equal to negative 3 over 9, or negative 1/3. Remember, we're not quite done. I'm sorry. A little bit of sleep this morning. Let's try this again. 9 over negative 3, or negative 3. Helps if I pay attention. Maybe I didn't have enough coffee this morning. So x is equal to minus 3. So we have that piece of information. Let's go stick that up in here and see if we can find out what y is supposed to be equal to. So I have minus a negative 3 minus y is equal to 8. So this looks like 3 minus y is equal to 8, or y turns out to be equal to negative 5. Okay? If I went a little bit fast, this becomes positive 3. 3 minus y is equal to 8. If I subtract 3 from both sides, minus y is equal to 5, or y turns out to be negative 5. So the ordered pair that's going to work for this solution using the adder subtraction is minus 3 minus 5. And that turns out to be our solution for problem number 13. Oh no, number 35, a word problem. I drew a little picture here. It says two angles are complementary, and it tells us the complementary angles both total up to be 90 degrees. So here's one, x, here's the other one, y. And when I add them both up, I'm going to get 90 degrees. So my first equation looks like x plus y is equal to 90. And the second equation is in the word part of it itself. It says their difference is 34, so I guess x minus y, the difference, is equal to 34. So I have two equations and two unknowns, and I can make a graph, I could do substitution, but in this lesson it's probably easier to just do the add or subtracting. So should we add or should we subtract? I think we should add, because if we add, these y's will disappear. So we're going to add these. So I'm going to get x plus x is 2x, and y plus a negative y is 0. And 90 plus 34, I think, is 124. So 2x is equal to 124, and x turns out to be 62. So if x turns out to be 62, something plus 62 is 90, I think you can figure out pretty rapidly that y turns out to be 28 degrees. So the two solutions are, the two angles are, for problem number 35, one angle was 62 and one angle was 28. Adder subtraction is pretty powerful, so is substitution. I'm not a big fan of graphing, but we do have three different techniques to solve the systems of two linear equations. That's it for today. See everybody tomorrow. Bye-bye.